Hello everyone. Today we're going to be going over absolute value equations and inequalities. There are only a few problems in this section. There should have been a couple more, so I'm going to be sure to hit on that for you. So the first problem is it's asking for which of the following has no solution. So we have the absolute value of x is greater than 0, and I'm going to talk more about absolute values. The absolute value of something is always a positive number because the absolute value is just, it represents the distance from 0. It's just a distance, so we don't have we say 6 feet, it's 6 feet. It doesn't matter if it's positive, it doesn't matter if it's negative, 6 feet in the hole, it's still 6 feet. So it's the distance a number is from 0. We don't care if it's a positive distance or a negative distance when it's in the absolute values. We just care that it's positive. It's a distance. I kind of give this one away on this problem because 0, 0, 0, and -5. Absolute value of x is greater than 0. Yes, because that's any number whatsoever that I put in here besides 0. So we have if x is 1, absolute value of 1, 1's greater than 0. -1, absolute value of -1 is positive 1, that's greater than 0. The one that's not true is going to be this, because an absolute value is always positive. Absolute value is always positive. The only exception to that would be 0 is kind of neither positive nor negative. The absolute value is always positive. So when we have the absolute value is less than -5, it's not less than -5 ever. This is not true. Absolute value will never be negative, and it will definitely not be less than a negative. Okay, let's see what our next problem looks like. So this lesson, they have equations and inequalities. There's some extra stuff to the inequalities that I'm going to hit on that's not so much in our assignment. I need to add more, but I will do that later, because I think we have one of every equation, but you could probably handle a couple more exceptions. But we have the absolute value of 3x equals 6. So if I had absolute values are always positive, but that means whatever is on the inside could be negative or positive and give us that positive answer. So whenever we have the absolute value of 3x equals 6, we're going to work both problems. And I always say to write the negative first, and we'll check these two when we're finished, and then the positive, because you're not going to forget to do the positive part of the equation. You'll forget to do the negative. So I say write the negative one first so that you remember to do both. Here, if there's not a sign and 3 is touching x, this is multiplication, so the opposite of multiplying is dividing. So we're going to divide by 3. And then anything divided by itself is 1. So x equals -6 divided by 3 is -2. Scoot over so y'all can see that better. Same thing here. We're dividing by 3 because the opposite of multiplication is division. And then 6 divided by 3 is 2. Now then we could check our answers. So if I put -2 in here, 3 times -2 is -6. Absolute value makes it +6. So our solution set, we are going to have -2. And then 3 times 2 is 6. Absolute value of 6 is 6. So our solution set, this is all you type in, but x equals -2 and 2. Those both work. Erase. Here we have the absolute value of 7x plus 5 equals 1. I'll make it like this since it looks like an absolute value. Okay, so the first thing we do is set our absolute value equation. We're going to take the absolute values off, set it equal to -1 because everybody forgets the negative, and a +1. So then we solve. I solve them one at a time. You can do them both simultaneously. Just remember to keep your operations in order and pay attention to your negatives. So -5, -1, subtract 5 is I spent $1 and I spent 5 more, so I've spent $6. And then the opposite of multiplication is division, so we divide by 7. This does not simplify, so x equals -6/7. If I did -6/7 times 7, I'd end up with -6 plus 5 would be -1. Absolute value of -1 is +1. Okay. We would subtract 5. 1 subtract 5 is -4. Divide by our 7. So x equals -4/7. When I do 7 times -4/7, we'd have -28 divided by 7 is -4. -4 plus 5 would be +1. Absolute value of +1 is 1. So both of these solutions work. So -6/7 and -4/7. Switch markers. So it's not terrible, especially when it's an equal sign. We just set one of them equal to a positive and one equal to a negative, and we solve. There is one thing though. If you have anything else on the side with the absolute value besides just absolute value equals, you have to move. Sorry, I dropped a pen. You're going to have to move your number, whatever's on that side, to the other side, so it's just absolute value equals. I'm trying to remember if I have one of those problems on here. If not, I'm going to make one. -4x equals 20. So here we set it equal to our -20, and it's okay that this is negative in here. It's in the absolute value, so this is fine, because if I take the absolute value of a negative, I get a positive. If we had -20 over here, though, it would not be true, because it is not an absolute value. But I set it equal to my negative, I set it equal to my positive, and now I will solve. So my x cannot be negative either, so when I divide here, I have to divide by a -4, because x needs to be positive. It needs to just be x equals. Here we have a negative divided by a negative, so it's positive. 20 divided by 4 is 5. Here, divide by your -4 again, because I need just x, not -x. Here we end up with x equals 20 divided by a -4 would be -5. If we check this, -4 times 5 would give us -20. Absolute value of -20 is 20. -4 times -5 would be +20. Absolute value of that is 20. So 5 and -5 are our answers here. Okay, I kind of want to show y'all an example real quick what I'm talking about. So if I had, let's say, four plus this here, what you'd have to do to be able to do your positive and negative, you can't just drop down right here and do 4 plus -4x equals -20, and 4 plus -4x equals +20. You'd have to move this 4 first. And you have to do inverse operations. So since this was a +4, we subtract 4 on both sides. And then I'd have the absolute value of -4x equals 16. And then I could do my -4x equals -16 and -4x equals +16, and then solve those. So if you have another like number with it. It could have been behind it. It could have been subtract 4, and I would have added 4 to this side. I just put it in the front because I didn't want to erase everything to show y'all an example. And then you solve just like you would. But to be able to do these, it has to be just absolute value equals. You can't have anything added or subtracted or multiplied on it. It has to just be absolute value equals something. Like if I had a 3 right here, I'd have to divide by 3 first. Okay, let me erase that, and then we'll get to the assignments. I sidetracked to be sure I show y'all that one because I think there is one on the test like that. I'm pretty sure I have one in our assignment. If not, I'll add one later. Not this semester, but later. Absolute value of x squared subtract 36 equals 0. So there's not a positive and a negative 0, it's just 0. So since the absolute value of this equals 0, I can't do a positive 0, I can't do a negative 0, I have just 0. When you're at this point, from our quadratics lesson 1.2, you have some options right here. Like I can add my 36 over, or I can factor this. So I'll go ahead and factor first. So there's a square root of x squared and there's a square root of 36. So I'm going to have x subtract 6 and x plus 6. Because factors of 36 that subtract to get 0, which would be 6 and 6. And since we're getting 0, they have to have opposite signs. And then x times x is x squared. Negative 6 times positive 6 is negative 36. And then you'd set both of your factors equal to 0. And we'd add our 6 here to get x equals 6. We'd subtract our 6 here to get x equals negative 6. And our answer would be 6 and negative 6. Now real quick, because we're just refreshing on this part. The other way you could solve this one would be to add our 36 to the other side and have x squared equals positive 36. And then we can do our square root method. So we take the square root of both sides. Just remember, when you take the square root of both sides, you end up with positive and negative 6. So this is our square root method, and this is factoring the difference of squares. Okay, kind of messed that up, but there's your 2 different methods on this. This, I know a lot of people find the square root method easier. You just have to remember to do positive and negative. But continuing. Okay, this one's our first inequality. So we have the absolute value of 2x is greater than 6. So when we have absolute value inequalities, we still have our positive 6 and our negative 6. But for our equation, or not our equation, our inequality to remain true, we're going to have do your negative first is less than negative 6. Because if I didn't flip my sign here, it wouldn't be true. And greater than 6, because if we put 0 in there, 0 times 2 is greater than 6. No, it's not. If I put negative 1 in there, negative 1 times 2 is negative 2. Is that greater than 6? No. So we have to be sure that we have less than. Be sure you change this sign. Change sign for less. Change sign, let's do 2 less than. I'm pretty sure I have a paper or a note that can go with this change sign to less than for negative. This one remains the same. Nobody misses this part. This is where they miss it. They miss changing it to the less than here. All right, and then we solve it like normal. So we would divide by 2. And I'd get x is less than negative 3. And we'd divide by 2 here. And we'd get x is greater than 3. They want you to write this in interval notation. So when we do interval notation with our absolute value, we just do both of these. Remember, interval notation is least to greatest. So this one right here is our negative infinity to negative 3. It doesn't have an equal to, so it's just a parenthesis. Then we have this fun union here because we have to put it with this one. So it's negative infinity to negative 3 or 3 to infinity because this union reads as an or. And our graph on this one, we'll put 0 here and we'll do negative 3 and 3. So 3 to infinity and negative 3 to negative infinity. Oh, this is one of those points when I wish y'all could like hop in and say something because I know these confuse people at first. So I'm trying to think of the questions that they usually ask me. Oh, yeah. Interval notation, negative infinity to positive infinity. Just remember, least to greatest for interval notation. All right, here we go. We have the absolute value of 1 subtract 2x is greater than 7. So since it's absolute value inequality, we go ahead and we make our negative one and our positive one. So since it's greater than, we're going to have less than the negative, and then 1 subtract 2x greater than the positive. The positive doesn't change. When you put your negative in there, you have to be paying attention though. All right, so we have a positive 1 subtract 2x is less than negative 7 or positive 7. Here we need to subtract 1 because it's positive 1. And then I have negative 2x is less than negative 7 subtract 1 is negative 8 because I spent $7 and then I spent 1 more. Here we're going to divide by a negative. Remember, when you divide by a negative, you have to flip your inequality. So negative 2 divided by negative 2 would be positive 1. You change your sign because we have divided by a negative, and if we do not change it, it is no longer a true inequality. Negative 8 divided by negative 2 would be a positive 4. This right here is going to throw off our interval notation if you're not paying attention in a second. Okay, go ahead and solve this one. So 1 subtract 1 is 0. 7 subtract 1 is 6. Divide by our negative 2. We are dividing by a negative in an inequality. So we're going to change our sign to be less than negative 3. When you do interval notation, it is always least to greatest. So our interval notation here, this one is smaller and it's less than. So it's going to go negative infinity to negative 3, or then this is our bigger one, 4 to infinity. So when we graph this, zero, negative 3, less than, it's not equal to, so it's a parenthesis, 2, 3, 4, parenthesis at 4, it's greater than, and it goes to positive infinity. Trying to think of questions that I might get on this one. I can't think of any off the top of my head. All right, I need to show y'all another problem that's not on here as well. So let's see. Let's do absolute value of 3 plus 2x is less than 11. Because we haven't had a less than one, so I want to be sure y'all get one of these. So the absolute value of 3 plus 2x is less than 11. When we have our absolute value, we know we have a positive and a negative, so we're going to go ahead and add our negative in here. But when we do this with an absolute value, if it's less than, that means that it's going to be between the negative and the positive. If it's greater than, it has to be on the outsides of it. But since this one's less than, it has to be between these two. So we put our absolute value between the negative and the positive. You can work them separate, just be sure that you know that they're going to close together when you do your interval notation. So here we would subtract 3 on all sides. So on our negative side, our positive side, and then I write it here so I remember to 3 subtract 3 is 0. Negative 11 subtract 3 would be a negative 14. 3 subtract 11, 8, 9, 10, 11 would be 8. And then when we divide right here, because we have to get x alone in the middle, we're going to divide by 2 on both sides. So negative 14 divided by 2 would give us a negative 7 is less than x, which is less than 4. When I go to write this one in interval notation, since x is between them, our interval notation would be negative 7 to 4. And our graph would be negative 7 to 4 with everything between it. That's a rough graph. Don't take that too serious. This wasn't on this homework set, but I think it's important that you know this because I don't know why it's not on your homework set. It should be. The last two that are on here are exceptions, which I guess I just wanted y'all to know them. And know what to do in case you saw them. So we have the absolute value of 5x is less than negative 4. Can an absolute value be anything but positive? So when I see this less than a negative, it's not true. So there's an option that says empty set. This one is solution set is empty. And then when you mark, like this is the option that they say. There's no solution to this, so it's the empty set, which means there is nothing that would satisfy this inequality. Nothing. So the solution set is the empty set, and then when you look at the graphs, you want the graph that has absolutely nothing on it. There's a couple that have dots on it. There's a couple that have graphs on it. Nothing. Nothing on the graph. Nothing on graph. Because this is not true. No less than a negative. Absolute values cannot be less than a negative. Okay. Then on the counter side of that, we have the absolute value of 3x is greater than or equal to negative 1. Absolute values are always positive. If it's greater than a negative, this is always true. So since this one's always true, that means absolutely anything you put in there is going to satisfy it. If I put in negative 4, 3 times negative 4 is negative 12, but the absolute value of that is 12. It's true. If I put 0 in there, 3 times 0, 0 is greater than negative 1. Anything whatsoever I put in here is going to be greater than a negative 1. So our interval notation here, since it's everything, is negative infinity to infinity. Not my best infinities. And then when you go to graph this one, it is absolutely all of the graphs. So it's the graph that has everything marked. Everything marked. And that is all I have for 1.6. If y'all have questions, if there's anything I need to emphasize more on or explain more, let me know. I will get on that. But at the moment I can't think of it, so let me know if there's something you'll need.